In this video, we're going to be talking about using the properties of exponents to simplify expressions that have rational exponents. So let's just review these rules real quick. We have the product rule that says if I have a base times a base, so they have to be the same base, I add the exponents. For example, if I had x squared times x cubed, this would give me x to the 5th power, right? 2 plus 3 would give me 5. We're going to do the same thing with these rational exponents, only now we're adding fractions. The power rule of exponents says that if I have a power to a power, so that quantity x squared cubed, we multiply. So 2 times 3 would give me x to the 6th. There's also other common rules. If I have quantities where there's products inside the parentheses, everything inside there would have to get that exponent. We've got fractions. Again, if it's in parentheses, that entire fraction gets the exponent, the numerator and denominator. And then we have the quotient rule that says that if we are dividing two quantities with the same base, we can subtract those exponents. So 5 minus 2 would give us 3. Again, we're just doing it with fractions now. Still true, anything to the 0 power is 1. And if I have a negative exponent, I have to take the reciprocal. So using these all together, we're now going to try to simplify these problems. So to start, we have b to the 1/3 times b to the 1/4. We have to ask ourselves, what property is this? What rule do I need to use? So I'm either going to add or multiply those exponents. Those two are most commonly mixed up. I see here we have a base times a base, right? There's two bases here. Base times a base is the product rule, so we have to add those exponents. So I have to add 1/3 plus 1/4. So I'm just going to do a little side work. But the rule is we're adding these exponents. To add fractions, we have another rule. We have to have a common denominator. So the LCD of 3 and 4 is 12. So I'm going to multiply 3 by 4 to make it 12. And I'm going to multiply 4 by 3 to make it 12. Whatever I do in the denominator, I do the exact same thing in the numerator to keep it equal. So now I have 4/12 plus 3/12, and I get 7/12. So b to the 1/3 times b to the 1/4, we add the exponents 1/3 plus 1/4 and get 7/12. So it's b to the 7/12 power. With the quotient rule, we are subtracting the exponents. So we have to subtract. In general, I like to not have a negative, right? So if I did 2/5 minus 12/5, I'm going to end up with a negative 10/5. But I don't really want a negative exponent. I want positive exponents. So I'm going to go back to this idea. We've done it before. If I had something in this form of x squared divided by x to the 6th, we can still use that subtraction rule, but I'm just going to make sure I keep track of where I had more x's to start. So 6 minus 2, the bigger number minus the smaller number is 4, but those remaining 4 x's are in the denominator, right? Because I had more x's in the denominator to start. I'm going to do the same thing here. I'm going to take the bigger fraction, which is 12/5, subtract the smaller fraction, which is 2/5, and get 10/5. But 10 divided by 5 is 2, so that whole thing simplifies down to 2. And then I'm going to make sure that I keep it wherever there were more to start, whichever number was bigger, that's where those leftovers stay. So 12/5 was bigger. This exponent of 2 is going to stay in the denominator. So now I have 1/9 squared And then I'm going to go ahead and simplify that. 9 squared is just 81. Okay, you could always just subtract, get a negative 10/5, and then make sure you take the reciprocal. You'll end up at the same place. Next one, I have a base times a base again. This time I'm adding negative 3/10 plus 6/10. So they already have a common denominator, so that's good. I just have to take negative 3 plus 6, and that would give me a positive 3. The denominator stays the same when we add and subtract. So negative 3/10 plus 6/10 is a positive 3/10 power. Alright, now we're going to talk about the power rule. Okay, power to a power, we said we're going to multiply. So now I'm multiplying 2/9. I'm going to use a different color here. So we're multiplying 2/9 times 3. I can take 3 and put it over 1 to make it a fraction. I look for common factors before I multiply. I see a 3 will divide out. So I end up with 2/3. So don't forget my base. This is now 11 to the 2/3 power. You do not need to go any further than that, because I would be taking the cube root of 11, which is a decimal number. You can leave it like this. Don't square it and try to take a cube root or anything like that. You're going to get a nasty decimal. So just leave it in the exact form with a positive exponent. Okay. Alright, now I've got some that are combining these rules together, right? And I have to follow some kind of order. For example, in this first one I have parentheses with the exponent. I need to simplify that first before I can use my quotient rule. I have inside the parentheses x to the 7/6 times y squared, and all of that is being taken to the 1/6 power. This is the power to the power rule, and I also have to make sure everything in there gets that exponent. Power to a power, we're multiplying. Okay, so x to the, I'm going to take 7/6, multiply it by 1/6. No common factors, so we end up with 7/36. Do the same thing with the y. I can put that 2/1. So now I have 2/1 times 1/6. Here a common factor of 2 divides out, and that simplifies down to 1/3. And then I didn't do anything in the denominator yet, so I'm going to leave that alone for a minute. Okay, now I'm not done because I still have too many x's and too many y's. This is the quotient rule. So again, I am subtracting. I have to subtract 36 minus 1/24. I have to have a common denominator here. The LCD of 36 and 24 is 72. I'm not going to go through that. We've done it in previous videos. You can go back and look at how to do that. And I have to get a common denominator. So to make 36 72, I multiply by 2, both the numerator and denominator. With the 24, I have to multiply by 3, numerator and denominator. And I'm going to rewrite that. I'm just going to rewrite it kind of up here because I'm running out of room. So now I've got 14/36, or 70 seconds. Sorry, we have a common denominator now. Minus 3/72. 14 minus 3 is 11/72. So I end up with, I had more x's in the numerator, so I end up with x to the 11/72 power. I need to do the same thing with the y's. The LCD of 3 and 24 is 24. So over here I just have to multiply by 8 to make that common. And now I have 8 24ths and 7 24ths. Again, I want to do the big minus the small. So I'm going to take 8 24ths minus 7 24ths and get y to the 1 24th power. So it was 8 24ths minus 7 24ths. 8 minus 7 is 1. The denominator stays the same. Again, I had more y's in the numerator, so that ends up in the numerator. So the x was in the numerator, the y was in the numerator. I don't need to write it as a fraction anymore. Alright, why don't you guys go ahead and take a minute and try examples F and G. Okay, there's some negative exponents. Just keep in mind that negative exponents take the reciprocal. Let's see how you did. We have the quantity a to the negative 1/3 power times b to the 2/5 power, all of that to the 1/4 power. So I have a power to a power. We need to make sure that everything in that parenthesis is getting that 1/4 exponent, and it's a power to a power rule, so we're going to multiply them together. So first I have negative 1/3 times 1/4. We multiply. 1 times 1 is 1. 3 times 4 is 12. And a negative times a positive is a negative. Same thing with the b. So 2 times, well actually I'm going to do some side work here. 2/5 times 1/4. We see there's a common factor of 2. So I divide out 2, divide out 2, and I end up with 1/10 for my exponent. Now I don't want negative exponents. I need positive exponents. So I take this a to the negative 1/12, take the reciprocal, so b stays in the numerator. It did not have a negative exponent. A is moving down to the denominator because it does have a negative exponent. Alright, one more. This one looks tough, but we're going to take it one step at a time. So I'm going to go ahead and I'm going to start by distributing that negative exponent in. Everything has to get it, including the 27. Every factor has to get it. 27 to the negative 2/3. I'm going to leave that alone for a minute. And then a, we have a negative times a negative is going to give us a positive. And I'm going to do a little side work here. 7/2 times 2/3. Those 2's divide out. I'm going to end up with a to the 7/3 power. All over, I still have a to the 5/24. And I just want to pick a different color here. Alright, so we've got this negative exponent we have to deal with. We have too many a's. We have to deal with that. With the negative exponent, all I have to do is take the reciprocal. So that 27 moves downstairs, becomes a positive 2/3. With the a's, I have to have a common denominator so that I can subtract them. So LCD for 24 and 3 is 24. I have to multiply 3 by 8, both numerator and denominator. So now I have 56, let's write it over here, 56 24ths minus 5, that's a minus there, 24ths. 56 minus 5 is 51. And the denominator stays the same. So 51 24ths. Alright, I have still a couple more things that I can do. The 27 to 2/3 power, I need to actually simplify that. So I have the cube root of 27 that I am going to square. In the numerator, that 51/24 can actually be simplified. 51 and 24 are both divisible by 3. So I'm going to divide out a common factor of 3, divide out a common factor of 3. Oops, wrong color. And now I have a to what power? 51 divided by 3 is 17. And 24 divided by 3 is 8. Okay, so that part is done. A to the 17th, 8. I take the cube root of 27. Cube root of 27 is 3. 3 times 3 times 3 is 27. And lastly, I have to square it. 3 squared is 9. So this is an A, that's a 9. And that's as far as we can go. So just take these problems one step at a time. It's very easy to lose negatives. It's very easy to do something wrong with your fractions. So remember, when we're adding and subtracting fractions, we have to have a common denominator. When we're multiplying and dividing, we don't.